yesterday? Is there anything anyone would like me to go over? I am happy to go over as much or as little because you didn't have a ton of time to work on everything yesterday. Kyla. How would we do number 5? This question here? Okay. Let's do it. I will grab my handy dandy book of paper. Here it is. Question number 5 says this. Melissa. So I didn't do an example where you had to make the chart yourself. I asked you to do 2 examples where you make the chart yourself. So here we go, making the chart. I got Melissa, I got Joyce. We want to figure out 2 things. We want their age now, and we want their age then, whenever then is. And then we're going to have to do something with their ages. So we're told that Melissa is 24 years younger than Joyce. So what is my variable going to be? J for Joyce. And Melissa's age now is what? J minus 24. In 2 years, Joyce will be 3 times as old as Melissa will be then. How old are they now? So this is one of those questions where, because we're not adding ages together, we're not combining them in any way, what are we going to need to do with the then ages? We had 2 styles of question. One where if we're adding their ages, we needed 1 expression for each. If we're not adding ages, then what do we got to do, Carolyn?
So, you know, the 2 years then, so we say J minus 24, J minus 24 plus 2.
Okay. So that's Melissa in 2 years from now.
Yeah. And then Joyce will be 3 times
In 2 years, Joyce will be 3 times as old as Melissa will be then. So Joyce is going to be 3 times J minus 24 plus 2. Joyce is also going to be, what's the other expression for Joyce? It's also, Joyce is going to be J plus 2. So what we've got to do is for when we're combining them, it's easy. We just have 1 expression for each and we add or subtract or whatever we have to do with them. For a style like this, where it says Joyce is going to be 3 times as old as Melissa will be then, now we're going to need 2 expressions for Joyce. One where it's a multiplier of Melissa's age, and one where you take her age now and add or subtract the amount of time. We know that Joyce is going to be both this and this, which means these 2 expressions have to be equal. So that's going to be your equation. So let's simplify this thing. It's going to be 3 bracket J minus 22, good, equals J plus 2. So then we're going to get 3J, as I distribute this thing in, minus 66 equals J plus 2, and then we solve. And I get Joyce is 34 years old, which means Melissa is 10. Which is there. It's letter T. Does that make sense, Kyla?
No.
Procedure? Okay. Anything else anyone wants to look at from the, what did they call the bug that the astronauts brought back from the moon? If there are no questions, then what did they call the bug that the astronauts brought back from the moon? A lunatic. Luna like moon. Tick, it's a bug. Maybe it's because it's probably because it's early morning that none of you are laughing hysterically. Or maybe you got all the giggles out last night. Come on, it's hilarious. Angel's very critical. It's not funny. We'd have to do better. Okay. Were we cool with both of these examples? Were you able to do them? No questions there? Okay, I'm not hearing any questions. Happy to go over anything anyone wants to go over. How about the, why did they arrest the automobile factory worker? Any questions from this page? Anything anyone wants to see done in front of the class? Going once, twice. I see that hand. T. T's a gutter. Let's do T. Didn't I do T yesterday?
Yeah. We did T.
Oh yeah, I totally did T. Here's T. So T says we want to find 3 consecutive even integers. So the evenness is how we set up the 2a, the 2a plus 2, and the 2a plus 4. Multiplying by 2 is going to guarantee evenness. And then alternating numbers, so like it's going to go, yeah, even, odd, even, odd. To get from this one to this one, we add 2. To get from this one to this one, we add 4. So we want, these are our 3 numbers, and we want to add the smallest and the largest to get 36. So it's going to be the 2a and the 2a plus 4. We solve for a, and then we plug it back in here, getting 16, 18, and 20. Does that help? I know I didn't do it fully. It's just kind of talking through the example that's there. Is that enough? Okay. Were we okay with K and R? K and R were a little bit different. K said, find 3 consecutive odd integers such that the sum of the smallest and 4 times the largest is 61. And R said, find 3 consecutive such that the 3 consecutive integers such that the sum of twice the smallest and 3 times the largest is 126. We can do R. Those 2 kinds of questions I would love to make sure that you're comfortable with for reasons that will be obvious later. Yes, it's recording. Thank you for asking, though. I've forgotten enough. Now there's one guy in my physics class who asks every day now, and now you guys know. I do appreciate you asking. Okay, R. Find 3 consecutive integers. So these ones don't care even or odd. They just want integers. So my 3 consecutive integers are going to be what? A plus 1, and A plus. Sure, we can go those 3. This will just give me 3 integers in a row. Do I know what they are? Not yet. Let's find them. I want these integers to sum how? I want twice the smallest and 3 times the largest. So how am I going to write that out? Kyla. So twice the smallest is 2a. Good. The important thing, you need to have that bracket there because you want to make sure you multiply 3 times the entire integer, which is the a plus 2, and that's going to equal 126. Now we can go through and solve. I think this is the hardest part of this question. At this point, I'm hoping you guys are comfortable with solving these things. We distribute 2a plus 3a plus 6 equals 126. So that's going to give me 5a. I'm going to subtract the 6 right away, is equal to 120. Divide by 5, divide by 5, a should equal 24. Did I do that right? Yes, 24. Which is going to make my 3 integers what? 24, 25, and 26. Love it. Which is, in fact, an option down there at the bottom. So this guy is 24, which makes this guy 25, which makes this guy 26. Those are my 3 integers. Comments, questions? Danny, does that make sense? Yeah. Okay. So why did they arrest the automobile factory worker? He took a break, spelled B-R-A-K-E, not B-R-E-A-K. He didn't take a rest. He stole a piece of a car. It's funny. Okay. We good? Okay, let's do some more. New style. Flip the page. Here we go. Money. Money, 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 money. Money. Okay. We have 2 more styles. Actually, that's not true. We have 3 more styles of problem. We're going to do money problems. Sorry. We've done the consecutive number problems. We've done the age problems. We've done, and I would call the first chunk kind of the generic word problems. like the ones that involve like shapes, ones that involve like costs of objects and numbers of objects, which is actually similar to the coin problems, believe it or not. They're just going to feel a little bit different. So I introduced this by doing, we introduced just kind of the generic problem, and I've given you some specific examples. The last two we're going to do is we're going to do distance, rate, and time problems, which you may or may not have done in science. No, this is going to be different. You're going to build formulas for this one. And like if so-and-so leaves New Jersey at 3, and Jeff leaves Pittsburgh at 4. Jeff's going to New Jersey and Sam is going to Pittsburgh. When do they when do they meet in the middle if so-and-so is going this fast and so-and-so is going this fast? Those kinds of questions. Or, Kyla is running away from Angel. Kyla gets a head start, but Angel is faster by this much. When does Angel catch Kyla? That kind of stuff. Those are the distance, rate, time problems you're going to look at. And then the last one is the rate of work problems. If Akam and Armand are cleaning a boat, and Akam works faster, 2 times faster than Armand, how long will it take them to complete the boat if Akam can do it in this much time and Armand can do it in this much time? Those kinds of questions. So like combined work questions. Or you're filling a bathtub with 2 hoses, and this one gives you this much water and this one gives you this much water. Or, how long does it take for them to fill the bathtub together? Those kinds of questions. So we got 3 more. Sorry? Why'd you put a hose in a bathtub? I don't know what's going on with your house. I don't ask questions about your bathtub. Why are you asking questions about bathtubs? I don't know why you'd use it. Maybe it's a bathtub outside for your dog. Anyway, coin problems. So similar style to what we've already done. This is actually going to be... because the values for coins are predetermined, this might actually be, you might actually be more comfortable with this than some of the stuff that we've looked at before. I encouraged a use of some charts here. You don't actually have to use the chart for this. It's not as vital for these ones as it is for the age ones, but this is a good tool to organize your thoughts. Yes, Carolyn? What are dimes? Yes, having grown up in a part of the world that does money so much better than we do, I will make sure that you're cool with all of our currency. A dime is 1/10 of a dollar. 10 cents. Like, what's like your fraction of a euro? What do you have? So dime is 10 cents. Yeah, you got the 2 cent piece. Never mind, I lied. Yeah, 1 cent. We got rid of our 1 cent. We used to call those pennies. Is the language we use for that here? Yeah, pennies were actually worth more to produce than they were because they were made of copper. The copper was more expensive than the value of the penny. It was weird. That's why we got rid of them. Okay, so this kind of style of question looks like this. A man has enough dimes and quarters to add up to $9.50. If he has 50 coins total, how many of each does he have? So this is where, again, there's a couple ways you can do this. You can do this using 2 variables. You can do this using 1 variable. I don't particularly care how you choose to do it, as long as you're comfortable with the technique you choose. So I've got dimes and quarters. I want to know, I'm told that they total, their dollar value is $9.50, and there's 50 coins total. How do we want to approach this? Does anyone have any ideas of how we tackle something like this? Yes, Carolyn. Yes. Yes, that is where we're going. Absolutely. To make your life easier, I would recommend decimals instead of fractions. So 1/4 is 0.25. And you said 0.25 quarters? Is that what you said? You said 1/4 times Oh, times x
and then 41
plus 0.1 some other variable. Okay, so here's what's going on. Here's what Carolyn is doing for those of us who might be concerned or confused. What Carolyn has done, I'm purposely not putting the variables in there quite yet. She has said, well, if we've got $9.50 total, to figure out how many of each coin we have, we're going to take the value of our quarters and multiply it by the number of our quarters, plus the value of our dimes times the number of the dimes. Why? Because that's what's going to give us, that's the money that's adding up to $9.50. If I told you you had 5 quarters, that's $1.25. If I told you you had 6 dimes, that's 60 cents. What would be the total value of 5 quarters and 6 dimes? $1.85. Because you take your amount for every quarter times the number of the quarters, and you add that to the dollar value for every dime times the number of dimes. That gives you a dollar value. So that's one expression that we're going to have here. The other expression that we're going to have here is what? What else do we, I mean, if we want to do this with 2 variables, we need 2 expressions. If you want to do this with 1 variable, we can do this here. Hands up if you want to see it with 2 variables. You want to see both? Okay, cool. Let's do both. Let's start with 1 variable because it's easier. We've got dimes, we've got quarters. If we want to do it with 1 variable, we have to pick a variable that represents one of these objects. Someone pick a variable to represent one of those objects. The first one I hear is the one we're going to use. Q is going to be, Q for quarters makes sense. Q for dimes would be confusing. Okay, now we want to do this with 1 variable. We've established we want to do this with 1 variable. So if Q is going to be quarters, then Q is what we're going to put in here. This is what Carolyn called X before, but yeah, we're going to use, I've heard now we're going to use Q. So I've got 0.25, and Q represents the number of quarters. How are we going to find the number of dimes as it relates to the number of quarters? No. Press it. 50 minus quarters. How many coins do I have total? 50. And if Q of them are quarters, how many of them are dimes? Well, 50, the total, minus the number of quarters, right? So the dimes is going to be 50 minus Q. So the purpose of the chart is just to organize your thoughts a little bit here. It's less important to do a chart with this style of question. The age ones are a lot more important, but if we're going to use it, let's throw it down. If the number of coins, the number of coins quarters is Q, then the value of Q quarters is going to be the value of 1 quarter times my number of quarters, 0.25 Q, which is how Carolyn gave us this piece. And the value of my dimes, well, 1 dime is worth $0.10 times the number of dimes that I have, which is going to be 50 minus Q. So this guy right here is going to be this expression right here. So then this is going to be 50 minus Q. And so using 1 variable, this is what we're going to solve. 950 equals 0.25 Q plus, now I can distribute this thing in here. So 0.10 times 50 is going to be 5, good. And then 0.10 times negative Q is going to be negative 0.1 Q. So now I can group and solve. Mr. Radney, what's going on?
Hey, how you doing?
Yeah, super duper.
Okay, yeah, super. My brain's kind of foggy.
Yeah.
And I didn't see an email that, remember we chatted the other day?
Yeah, I'm going to send this to you during my prep.
Okay, cool. Because
Yeah.
I'm like, I don't think I see an email.
I haven't sent it yet.
Okay, because are you still thinking along those same lines about psych?
Yeah.
That you're
Yeah.
okay with?
Yeah.
Okay. I
And
didn't see it.
it
and I
happened,
thought, okay,
yes,
I wonder
no.
if it just didn't come
I
through.
would, yes, no, it's been less urgent for me to send it because after my conversation with DeVries, I had a conversation with you,
Yeah.
and then Bo just walked into my room and started asking me questions about it. So then I talked to him too.
Okay.
So
Okay.
between the three of you,
Oh, that's good.
all of you individually have the message, and so I am going to send it just to make sure I've got it down there in writing.
Yeah,
But
because then
because
it's-
the guys who are working on it,
Yeah,
you know,
because
Bo
then
knows.
and
So
it's not like, oh, I think I saw it, I think I heard him say that.
Yeah.
Versus, okay, here it is.
yeah,
Whatever.
no, I'm going to send that email. Yeah, but as soon as I had that conversation with Bo, it became less vital.
Yeah. Okay. Perfect.
Okay, so let's keep going. I can group this, so what am I going to get? What's my expression going to look like after I group it? Carolyn.
9.5 equals 0.155
Okay, so we're now subtracting 5. So we're going to get 4.5 equals 0.15q. So this is where, if you don't have a calculator handy, you can use one of the techniques that I introduced to you earlier. If I want to get rid of these decimals, I'm going to do what? Do not turn them into fractions. To move the decimal, how do I do that? What do I have to do to move the decimal? Yeah, so I'm multiplying both of these by 100. Yes. So this is going to become 450 equals 15q, because I multiplied by 100 and I multiplied by 100. Again, if we're doing this without a calculator, this becomes, that's the technique you want to use. And then this should become somewhat obvious. What's 450 divided by 15? It's 30. Because 45 divided by 15 is 3. So 450 divided by 15 is going to be 30, 30. No, it's going to be 30. Because by multiplying by 100 here, I got rid of my decimals. Doesn't matter. 4.5 divided by 0.15 is still going to be 30. So I've got 30 quarters. How many dimes do I have?
20.
So that's the technique with one variable. Sorry? It's building for all of these, it's building the equation that's the hard part. I've taught you all the solving techniques already. Solving these things shouldn't be the issue. It's the building it that I expect to be a challenge. Now, the only thing that's going to change here moving forward is the kinds of coins I give you. Sometimes it's going to be, I might say, dimes and nickels. It might be dimes, quarters, and nickels. It might be, I might tell you that there's $half. If it's a $half, which you guys have never seen before, perhaps, a $half is a coin worth what? It's a 50-cent coin. Which I think, do you guys have 50-cent coins in the euro, Carolyn? You have 50-cent coins? Sorry? Yeah, you got a lot of coins. If you're making change in Europe, it gets really heavy. So this is the technique for one variable. I'll show you the technique for two variables using the practice one down here. Sally, if you're going to use two variables, here's how it's going to look. Sally has 70 coins, all of which are dimes and quarters. If the total value of the coins is 1045, how many of each coin does she have? So if we're going to use two variables, what we're going to do here is we're going to call dimes equal to D and quarters equal to Q. So maybe actually I'm going to make a note here. This is one variable up top. Down here, it's the exact same style of question using two variables. And you're going to see here it's exactly the same as what we did before. Now, what do I know about my dimes and quarters? Dimes plus quarters is going to give me what, Rebecca?
10,045 cents.
Actually, no. The value of my dimes plus the value of my quarters is going to give me 1045. But what do I, sorry, Carolyn? 70. Because I've got 70 coins total. So what I'm going to do here is I'm going to say, well, D plus Q equals 70. Because D just represents the number of dimes and Q represents the number of quarters. Now I've got to go through and I've got to build my equation to express the number of sorry, the value of, not the number of, the value of each coin. So what is this equation going to look like here? Yes, Carolyn, I know you know. I'll give someone else a shot. How do I take my number of dimes and my number of quarters and convert it into a dollar value? Yeah. I'm going to take the value for my quarter and I'm going to multiply it by the number of quarters. Likewise, I'm going to do what with my dimes? And the value of a dime is 0.1. Well, 0.10 if it makes it easier to view these things as dollars. So I'm going to get 10 cents, 0.10, times D plus 0.25Q equals 1045. This here becomes my expression for the amount of money we actually have. The value for one of the coins times the number of coins plus the value of the coin times the other coin equals my total value of all of my coins. Now, with two variables, it's what I did before. I have to take one of these equations and I have to solve them for one of the variables, and then I'm going to substitute it into the other one. So which equation do we want to which equation do we want to use to isolate a variable? 10 meet. This one is the easier one to do. There's nothing to divide. You don't want to divide, especially since these are already decimals. It's just going to get nuts. So which one do you want to isolate for 10 meet? You want to isolate for D. So how do you get D by itself here? If I subtract Q on both sides, I'm going to get D equals 70 minus Q. This is where we just jumped in before when we had the chart. So two variables means I just have to do this extra piece of work instead of just thinking it through up here. Otherwise, it follows now exactly the same. I take my expression for D and I put it in the other equation for D. So I'm going to get 0.10 bracket 70 minus Q bracket plus 0.25Q equals 1045. And now you can solve this thing from here. I'm going to let you solve this one. So I'm just going to go dot, dot, dot. I'm going to give you some time to do it. What I'm going to tell you now is that your quarters should equal 23, and therefore your dimes should equal 47. That's what you're aiming for. I want you to solve it now real quick here on your own. Once you've done that, assuming you get D and Q done properly, I want you to flip the page and I want you to try these two as well. I'm going to come float around and see how we do. You are allowed to use calculators. It'd be faster if you can do it without, but you're welcome to.
Yeah, but do we have, like, I can't, like, the first step I wanted to is
Same techniques as that. Same techniques you've done before. Let me know if you need a hand with any part of this. Once you finish the first one, which I've given you the answer for, flip to the next page to the next two.
so 0. Oh, I didn't know. I can't. Yeah.
Oh, that's not really an issue. No way about that? So we lost? Okay. Lost badly?
Or 0.10. Yeah. Hopefully they work about that year now. Do you have it?
70 minus 2. Okay, so
Here.
then we have 7
Multiply this one by 100.
1, 0,
8 decimal places plus 50 equals to 70. 50.
and then I guess we can
Yep, drop T right there. 0.25 T.
yeah. Okay.
Okay, now, what's our answer?
Or negative. Oh yeah, minus.
Yeah, because it's the same number of each edge in the same verb, yeah.
0.102 plus
Yeah.
So we subtracted 7 from each side, so that connects up to 7, but then we're left with this negative sign.
How did you go from
So then this is a negative. So you're left with
1045 and
negative 0.1. Oh, right. Yeah, sorry. So then we can add the 0.25. Oh, we can add the 0.25.
write it out for us. It might not make sense looking at it in your head, but a D equals Q.
Yeah.
That gives you an expression to shove into the other one.
Yeah. Okay. Yeah. Yeah, and and then we divide it by 4. Or no, we'll divide by 100. Yeah. So then we have
Okay, how we doing? Yeah, you see where you're shoving it together. So you don't have, like, there's two techniques, like, yeah, sorry, we did something never mind. Forget what I was about saying. Yes, because we're used to If we're stuck, let me know. I'm happy to assist. We're stuck, okay? Did you figure out this one? Okay. Okay. It is very similar with one little switch. $5.25, okay?
And then we have the same number of each point.
Okay.
So
So start writing things up. Same as before. Define your variables. Set up your equation. Solve. Just gotta start somewhere.
Should we solve for one times here or two? I mean, I guess if we solve for one, we get both done.
Why if you solve for one, you get
And we just subtract it. Or whatever. And then we get the other one. Usually.
okay.
So, okay. We can solve for
Are you, Carolyn, you checking? You want to ask for something? Okay, one second. No. You're defining. Start with what we've done. Defining your variables and then start building things. That's not true. Because Q and D represent the number of each coin. The number 5 quarters is their value. Everything's related to nickels. Well, the pennies are related to the pennies and nickels are the same.
Then the other thing.
Okay, well, let's set one of the use either one.
D would be. Oh, sorry. D would be Q minus 15.
How do you know where's the 15 coming from?
25 minus 10.
You can't combine them with different variables.
So what I'm trying to get quarters.
Yeah, you're making things up.
Before.
That's not what we did before. You're making things up. Where did this come from? This is not true. 5.25 minus Q is not equal to D. Because this is a dollar value and Q is the number of coins. Can't relate those. Guys, be really careful with the next one I assign. Because I see some of you trying to make an equation relating the number of coins to their dollar value in ways you cannot do that. Dollars does not equal the number of things you have. 525 is not equal to D plus Q. $5.25 equals the number of dimes times their value plus number of quarters times their value. You still need, if you're setting up two variables, you still need two equations. You can't use the same information for two equations and expect this thing to work. There's a very important detail for that top question. Some of you have found it already. The first thing it says is, oh no, the last thing it says is using the same number of each coin. So how does that relate the number of dimes and the number of quarters? It says the same amount of each quarter. How does that, of each coin? How does that relate the dimes and quarters? They are equal. So if you're going to use variables for this, that means that D for dimes is going to equal Q, the number of quarters. So your other equation is just going to be D equals Q. And then substitute this all. Because if you're using the same number of each coin, D is just going to equal Q. Substitute this all. Or you can set it up like that, where you use the same variable for each one.
Okay, so after we do that, then do we put the 0.25 times Q and then 0.10 times D?
Yeah.
sense. 0 and 8 plus 0, 5, 8 is quarters of 0, 6 plus 1 times equals 5.
Mine just, this doesn't make sense.
This right here. That's gonna fix it. Yes. Yeah.
These are both true statements.
Yes. Yeah, that's right. Yeah. But you know Q equals D. So wherever there was a D, you could substitute it with Q. So Nika, in that hole you have right there, it's also going to be Q, yeah. Well, because D equals Q. You wrote that down.
I would write 0.25 Q plus 0.10 Q.
Yeah, because Q also equals the number of dimes. Q is quarters and Q is dimes, because the number of quarters and dimes are equal, which you wrote down. Yes, the 50 came from the total number of points, which I don't tell you. There doesn't tell you what the total number of points is. Okay, are we stuck, ladies? Okay. So honey's putting both hands up in the air. She gets up. Whoa, we've nothing written down. We're all stuck? Have we attempted? None of us have tried anything. None of us have anything written down. Where are we? But if you look at it, tell me what's wrong. Okay, so this is, remember why I said it wasn't true? Because this is value. So what are you going to have to do to make this thing true? Take your dimes and multiply by? A dime. Which is a dime worth. It's 0.10, it's not 0.10, it's 0.10. Okay. So this is going to be 0.10D plus 0.2Q. That's what that is. It's value for the money. It's the value of the coin times the number of points. If it helps, make a chart. Here we go. Like where it is, yes. This one is good.
I got 0.25.
So that's one. Now you do a second equation. Okay, there's a whole bunch of us stuck on this one, so let's now take some time and do it together. This one, the top one, the one that has all the space. Here we go. Let's do it together. So I want to show you what this thing looks like using the chart, because that's actually going to help us with the second one. Let's practice. How can a bill of $5.25 be paid with quarters and dimes? Okay, so I've got dimes. I've got quarters. I'm going to build myself a chart. I was afraid of this. As soon as I said it's not super necessary, but it's a useful tool, a whole bunch of you are like, yeah, we're not doing it. We're going to make our lives a little bit easier, especially if we have trouble picturing this in our head. Write out thing.
This one is number of coins. This one is value. Okay, so what does the question tell us? The question tells us we want a bill of $5.25 to be paid with quarters and dimes. So we know that the value of my dimes and the value of my quarters, this is going to add to give me $5.25. So that's one expression I'm going to need here. This guy is going to go here. This guy's going to go here. But first we need to figure out how many coins of each I have. So I need to pick a variable for one of these things. Q for quarters works for me. How does quarters relate to dimes? They're the same. So what does that mean I can use for a variable for my dimes? I can use the same variable because I have the same number of each coin. So that's going to make my dimes also equal to Q. So then for the value, I take the value of a dime multiplied by the number of dimes. So this is going to be 0.10Q, and my quarters is going to be 0.25Q. So then this and this is what's going to end up in this expression here. 0.10Q plus 0.25Q equals 5.25. And the reason I can use the same variable is because we're told that the amount of each is the same. Setting this up is the hardest part. Use a chart if you struggle to do this in your head. And I'm sensing that a lot of you are struggling to do this in your head, and that's fine. Use the tools then that'll make your life easier. This becomes easy then to solve, yeah? Okay, so I'll leave this to you. What you're looking for is dimes equal quarters equals 15 of each. Okay, so then the next one is going to look like this. Let's set up the chart again. This one says a piggy bank contains $5.05 in pennies, nickels, dimes, and quarters. So the first thing you should do, unless you can do this easily in your head, is to build a chart using all of those coins. I want pennies. I want nickels. I want dimes. I want quarters. This becomes really easy if you set the chart up. This one is the number. This one is the value. Okay. So we got 4 coins here, and they're all related to each other. How are they related to each other? Give me one relation, someone. Carolyn, give me one. Pennies and nickels are the same. If pennies and nickels are the same, what can I do with that information? A single variable to represent pennies and nickels. Which variable should I use to represent pennies and nickels, Carolyn? P. Okay? So if pennies equals P, nickels also equals P because there are the same number of nickels and pennies. We cool with that idea? Okay. Amina. We're told that there are 3 times as many quarters as pennies. So pennies was P, so quarters is going to be 3P. Love that. And then the last one, 10 meat, is what?
5 plus
Because there's 5 more dimes than nickels. 5 more dimes than nickels. Yes. So I take my nickels and I add 5. Nickels was P, so dimes is going to be P plus 5. So now I've really easily just set up in this chart a relationship for all of these things relating to a single variable. Use the tools you have at your disposal to make your life easier. Don't try and do everything in your head, because that's where you're going to stumble every time. So then the value for my pennies is going to be what? What's the value of a single penny? Carolyn? 0.01. 1 cent times the number of pennies. What's the value of my nickels? 0.05 times the number of nickels, P. How am I going to find the value for all my dimes? 0.10 times bracket P plus 5. So then what's the value going to be for my quarters? the value of 1 quarter, 0.25 times the number of quarters, 3p. And now what am I going to do with this whole stack of value expressions? Carolyn.
Add them together and equal to 5.
We're going to add them up, and they're going to equal 5.05 because we're told that the total value of the piggy bank is $5.05. So we're going to get 0.01p plus 0.05p plus 0.10 bracket p plus 5 bracket plus 0.253p equals $5.05, and then this becomes really easy to solve. Assuming you don't do too much in your head and show me your work, because that is where you're going to mess this up every time, is by carrying all this around in your head. There is value to the chart. I've walked around and I've seen a bunch of you don't need it. That's great. But if you're stuck on this at all, organize your thoughts using a chart like this. I'll let you solve this on your own. What you're looking for is 5 pennies, 5 nickels, 10 dimes, and 15 quarters. I'll let you verify that. Here is what I want you to do. Flip the page, and you will see there are 2 things here. This one says, how did the doe win the big animal race? Do I want you to do the second page too? I want you to do this guy here. And then I want you to flip the page, and I want you to do odds. Do I want odds? No, I don't want odds. I want evens. I want evens on this page. Okay? I want you to practice this until you get comfortable with the techniques. I want you to figure out how the doe won the big animal race, and I want you to do evens on the coin problems. Use what little time you have left. There's like 3 or 4 minutes left in class. And then may the force be with you. Good luck, all of you, working on your science comics. I see a few of those out and about. But this is what I want you to work on now.